This is still section 1.3, part B, on scattergrams. Okay, so we're going to assume that a situation can be described using variables t and p, and that p depends on t. We're going to call t the independent variable, and we'll call p the dependent variable since p depends on t. In example 3, we're going to practice identifying the dependent and independent values. We're going to let n be the number of words in a document, and let t be the number of minutes that it takes to type the document. It's easier to identify which one depends on the other, so we're going to find the dependent first. The number of words and the number of minutes it takes to type. So the number of minutes that it takes to type is going to depend on the number of words. That's going to mean that t is our dependent and n is our independent. The number of words is independent of the amount of time, but the time that it takes to type will be dependent on the length of the document or the number of words. Okay? Let's try it again in part B. Let L be the length of a person's hair in inches at t weeks since the hair was last cut. Okay? Well, the length of a person's hair is going to depend on how long it's been since it was cut. So length is going to be dependent, and the time since it was last cut, t in weeks, is going to be independent. Let's look at part C. H is the height of an object dropped from a building 2 seconds after it was released. Well, the time here has to be the height, I meant to say, sorry, I got this backwards. The height of the object has to be dependent on how long it was since it was dropped. So the dependent variable has to be h, the independent variable has to be t, right? When the object starts falling, the height of the object depends on how long it has been since it was released. All right, in our definition here, a blank is a pair of numbers of the form x, y. That's an ordered pair. And in an ordered pair, the first number is always the independent variable, called the x-coordinate, and the second number is the dependent variable, called the y-coordinate. Okay, so I don't always use the letters x and y, but whatever I do use depends on the letters in the situation. But I do always order it independent first, then dependent. So the ordered pairs for these guys up here would be n, t, t, L, and t, h, based on the letters I've chosen for independent and dependent. Okay, that always needs to be in the order independent first. Let's look at the next page. In example 4, P is the percentage of Americans who always wear seatbelts at t years since 1990. Okay. What's the independent variable and what is the dependent variable? Well, the independent variable has to be t, since the percentage of Americans is going to depend on what year it is. So the independent variable has to be t, because the dependent variable is going to be p. P depends on t. Okay? So I'm going to list the ordered pairs that correspond to this data. Now, note that we are talking about years since 1990. So 1992 isn't the actual t value. T is just years since 1990. The actual t value here would be 2. 2 years since 1990. The t value here would be 6. The t value here would be 10, 14, 18, and 21, etc. These are my values of t. And these are my values of p. The percent is just going to be that value. So the ordered pairs are going to be 2,70, 6,75, 10,79, 14,83, etc., 18,87, and 21,91. It is very common when a year value is used as the independent value that you'll have a starting year and you will talk about just values beyond that year. Otherwise, you're going to have to go very, very far down your number line until you can get to values as high as 2011. You'd rather have just a number that goes from a certain value so that you have a smaller independent value. Okay, changing gears. When we plot points that are not being used to describe authentic situations, then we call the horizontal axis the x-axis and the vertical axis the y-axis. So we label those right here. We have our x-axis as the horizontal axis and our y-axis as the vertical axis. Okay, x is the independent variable, y is the dependent variable. So we have our independent on the horizontal axis and our dependent on the vertical axis. All right, a few more labels to fill in this chart. All right, the place where the two axes cross is called the origin, and that's the point 0, 0, right down here. 0, 0, the x-axis will increase 1, 2, 3, 2, etc. to the right, and decrease -1, -2, -3, etc. to the left. The y-axis will increase 1, 2, 3, etc. up, and decrease -1, -2, -3, etc. down. Okay, and the last four boxes are for naming the quadrants. The first quadrant up in the upper right hand corner is quadrant 1. We use Roman numerals to name them, so quadrant 1, quadrant 2. They go around in a C shape from there. Continuing, we have quadrant 3, and quadrant 4. Referencing the quadrant is a handy way of helping someone identify where a point is. All right, let's look at the next page in the back here. I'm going to plot the following ordered pairs, and I'm going to label each of them. Okay, so there are 8 ordered pairs here. A is the ordered pair 2, 8. Remember that these are all in the order x, y, which means that the first number is the number that we go along in the x direction, and the second number is the number that we go along in the y direction. So 2, 8, I'm going to go from the center 2 over and 8 up. This is the ordered pair 2, 8 for A. Okay. In part B, 8, 2, this one I would have to go 8 along the x-axis, but before you draw anything, go up 2 along the y direction. This is my ordered pair for B, 8, 2. Okay. C, 4, -2, so I go along the x-axis for 4 units, and I go down 2 in the y direction. That would be C. D, -1 in the x direction, and a +3 in the y direction is going to put us up here in quadrant 2. E, -5 in the x direction and -2 in the y direction is going to put us down there in quadrant 3. F, 0, 7. So 0 along the x, which means I stay in the center, but then I go up 7. G, 4, 0. So I go 4 in the x direction and don't increase or decrease in the y direction. So stay right there. And last, H just has a fraction in it, which is just to get us a point that's in the middle of a box. So I go -1 in the x direction and I go down 2.5. It's going to be like right there in the middle. Okay, so you don't have perfect numbers all the time. It's a lot easier to graph whole numbers, but you can graph fractions by estimating. Okay, so quick summary involving the quadrants. We'll kind of write it down here in the bottom. Just want to list which points are in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so in quadrant 1, there are 2 points, points A and B. In quadrant 2, there is 1 point, point D. In quadrant 3, there are 2 points, E and H. And there is 1 point in quadrant C. That also leaves several points that are in none of the quadrants because they're actually on one of the axes. So points F and G are both not in any of the quadrants because they're on one of the axes. Okay, let's go on to our next page. Example 6. This example is about determining the meaning of an ordered pair. Okay, so let n be the number of words in a document and let t be the number of minutes that it takes to type it. We've already seen this example and we know that the number of words is going to be independent and t is going to be dependent. So just as a reminder, we saw this example on one of the previous pages. So we already know that the number of minutes depends on the number of words. We already had that relationship set up. Okay, I need to know that before I start this one because the order in the ordered pair is always independent, dependent. So ordered pairs of this format were always n, t, which means that 400 is n, 8 is t. So if I were to phrase this in a sentence, it means that n, the number of words, 400 words. So a 400 word document takes t being 8, so 8 minutes to type. All right, in part B, let L be the length of a candle in inches at t minutes since the candle was lit. All right, so the length will depend on how long it's been since the candle was lit. So we have our dependent L and our independent being time. Again, it's important because we need to know what each of these stands for so I can figure out if 30 is the length or the time. But the independent always comes first in an ordered pair, so my ordered pair must be t, L. So that means 30 is the time. So after 30 minutes, the candle had a length of 6, so it was 6 inches long. Okay. The next definition is about a scattergram. So a scattergram is a plot of ordered pairs that have a relationship, so it's data usually. So this one right here, I'm going to draw a scattergram. You can see that there's a grid with some scale already set up. I'm going to draw a scattergram for this set of data. And it's already the data from example 2, so I know that I've already identified the percentage as being dependent on the year. So I have my independent and my dependent. And I also know that my independent is actually the 2, 6, 10, 14, 18, and 21 because I'm talking about years since 1990. So again, it's the same example that we'd seen before. Okay. So I want to graph this. So I'm going to start with 270. So independent is 2, dependent is 70. That's right here. Then I want 675. Then 1079. That's just below 80. Then 1483. So a little over halfway. Then 1887, so just under halfway between 85 and 90. And last 21, which is halfway between 20 and 22, and up here at 91, so just over 90. Right. Now, this scattergram, by the way, is only showing me quadrant 1, and that's actually pretty common when you have data. If you wanted to see the other quadrants, they would be over here, 1, 2, 3, 4, but I only see quadrant 1 if both my independent and dependent have only positive possible values. So positive values, and just showing quadrant 1 right here. Okay. Last, I first label my axes. So this is my t-axis for the independent, and p-axis for my dependent. All right. On the next page, I go into the next section. So we'll stop this video.